Okay, moving into trigonometry. Now, maybe I am a sucker for punishment. I don't know, but this is my favorite chapter. There's something about trigonometry. I don't know. I like it, and it's very, very important because you use this extensively in calculus. So this is one of these things that you definitely need to pay attention to, make sure you understand, because at some point you probably will take calculus. So let's see what we can do with right triangle trig. Now we're going to start with some basic stuff that you should be familiar with. This is just your basic right triangle stuff. You know, SOHCAHTOA, sine is opposite over hypotenuse, and it's in reference to the angle. So here the angle is, I believe that's omega. I really need to study my Greek letters. But sine of the angle is opposite, which would be b over hypotenuse, which is c. Cosine is adjacent over hypotenuse, and adjacent means next to. So the adjacent side, a, the hypotenuse in this triangle is c. So cosine was adjacent over hypotenuse, or a over c. Tangent is opposite over adjacent. And some of the mnemonic devices that you could use, SOHCAHTOA just rolls off the tongue. The problem is a lot of people misspell SOHCAHTOA, which really blows it up. But it's sine is opposite over hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. If you have a hard time spelling SOHCAHTOA, you could use something that's a little bit easier to remember, like some old hippie came along here tripping on acid. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Some people may argue how appropriate it is that we use something about hippies and acids to remember stuff, but you know it works. All right. Some reciprocal trig identities. You have sine, cosine, and tangent. Those are your big three. Sometimes you have to use one to derive another. Tangent is sine over cosine. Cotangent is cosine over sine, or 1 over tangent, either one. Your secant theta is 1 over cosine, and cosecant is 1 over sine. That is stuff you should have seen in Algebra 2, so hopefully I don't have to beat you to death with that stuff. But you do need to know that those are the reciprocals. One thing that helps me remember secant and cosecant sine go together is you always pair the s with the c. The reciprocal of secant is cosine. S goes with c. The reciprocal of sine, if you flip sine, you get cosecant. S goes with c. I have no idea if that helps you. For some reason, it works for me. If it doesn't work for you, then you can come up with your own little devices. But those are your reciprocal identities. So let's use this a little bit. Find the exact values of these 6 trig functions, and there are 6 of them. So we will have sine of theta. Sine is opposite over hypotenuse, so opposite would be the 12, hypotenuse is 37, and you would stop there. That's all you have to do. Cosine theta is adjacent, 35, over hypotenuse, 37. Tangent theta is opposite over adjacent, so here's my angle. Opposite is 12, adjacent is 35. And then for the other 3, you have cotangent theta, you have secant theta, and you have cosecant theta. For these 3, since I already have the main 3, I just start flipping them. I know that cotangent is the reciprocal of tangent, so I'll just flip those 2, and they are they're reciprocals of each other, so cotangent is going to be 35 over 12. Secant goes with cosine, c goes with s. So secant and cosine are reciprocals, that means secant is going to be 37 over 35. Same thing for sine and cosecant. If you flip sine, you get 37 over 12, and there are the 6 trig identities, or 6 trig values for that triangle. That's all there is to it. Don't have to do any work. You don't have to give me, please don't give me the decimal. I prefer the fraction. Let's see, moving on. Find the exact values of the 6 trig functions. This one's a little trickier because here I give you one, and you need to find the remaining 6. So let me jot those down real quick. There we go. So I jot those down, and I've got to find the remaining 5 of the 6 trig functions when all they told you was that sine theta is 3 over 5. Well, if you remember our friend SOHCAHTOA, by the way, SOHCAHTOA, I don't know if y'all know this. I'm going to give you a little history lesson. SOHCAHTOA was actually Native American back in the days of exploration and expanding the United States from the 13 colonies on west to the Pacific Ocean. And SOHCAHTOA, unbeknownst to most, actually aided Lewis and Clark on their journeys exploring the Louisiana Purchase. Everyone knows of Sacagawea, and Sacagawea helped them with the geography of the land. They helped Sacagawea helped with the interaction of the other locals and really was more of their survival guide. But SOHCAHTOA joined them on that trip, and SOHCAHTOA was a math tutor for Lewis and Clark, so they could be ready for the ACT and the graduation exam when they returned home from their trip exploring the Louisiana Purchase. So a little unknown history, little known history, should I say. So SOHCAHTOA, our Native American friend, we're going to have to use her, and I kind of get distracted there. So anyway, so sine theta, if you remember SOHCAHTOA teaches us that sine is opposite over hypotenuse. So when I tell you that sine is 3/5, I'm giving you the opposite side, and I'm giving you the hypotenuse, or at least the ratio of opposite to hypotenuse. So what I'm actually going to do is I'm just going to create a new triangle, draw one on my own, because I'm pretty smart. I know what a triangle looks like. Wow, check it out. So there's my triangle. And I know that if I have some angle theta, there's a right angle, you can put theta wherever the heck you want to. It can be in the top angle, the bottom angle, as long as it's not the right angle. So I'm going to put my theta right here. That's a stupid looking theta. There's my theta. And I know that opposite theta is going to be 3, so this side is 3. The hypotenuse is going to be 5. And then we can do the nice little Pythagorean theorem to find the adjacent side. So 3 squared plus a squared is 5 squared. A squared equals 25 minus 9 is 16, and a is going to be 4. Of course, hopefully you just know that 3, 4, 5 are the sides of a right triangle, of one special right triangle. So I know that my adjacent side is 4, and now that I have all 3 sides of my triangle, I can fill down cosine through cosecant. Cosine is adjacent, which is 4, over hypotenuse, which is 5. Tangent is opposite, which is 3, over adjacent, which is 4. And then once I get those 3, we just start flipping. Cotangent is the reciprocal of tangent. Cosine and secant are reciprocals. And sine and cosecant are reciprocals. And so there you go. So if I give you something like this, you actually need to generate the triangle to answer the rest of the questions. And that's going to be a pretty common strategy for this year. Let's see, moving on, solve for x. So now I'm asking you to solve for a variable that I put in the triangle. I don't need, well, I don't know why I put x, y, and z right here, so let's get rid of those. I want to solve for x. Now this is a right triangle, which means we can use our old friend SOHCAHTOA. Old SOHCAHTOA. She was cute too. It's a shame that she escaped the history books. So we have SOHCAHTOA. And I'm looking here, I have an angle 35, and I'll look at what the 2 sides are that we're dealing with. We have the opposite and the hypotenuse. So I have to think, which trig function can I use if I have opposite and hypotenuse? Well, SOHCAHTOA is over here, opposite and hypotenuse, that's sine. So what I'm going to do is I'm going to set up sine 35 degrees is equal to opposite x divided by 22. And then we solve that equation. We're trying to solve for x, so if it's x divided by 22, we will multiply by 22. Over here they cancel, and I get 22 times the sine of 35 degrees is x. And here's where we dive into the calculator. We will just throw this in the calculator, and there are a couple of things that you need to be aware of. I'm going to show you here. 8 minutes, not too bad. So let's see, where am I? There it is. So looking at our calculator, I'm using the TI-84 here. Let me turn it on. And we're going to punch in 22 sine of 35 to get this answer. There's one thing you always need to be aware of in this class, and that is how the angle is measured. There's actually 2 different ways to measure an angle. One of them is in degrees, which is what you're familiar with. The other one is in radians. It's just like feet and meters. 2 different ways to measure lengths. There are 2 different ways to measure angles, and this is radian or degrees, and you have to make sure your calculator knows that when you type in sine of 35 degrees, that you are actually doing the sine of 35 degrees. So if I type in sine 35, I get negative 0.428, but is it 35 degrees or radians? And you really have to make sure you're in the right mode. So what we'll do is we'll hit the mode button. See, here's the mode button right here. So I'm going to hit that, and it pops up this screen. And if you look, it is in radian mode. I have to make sure it flips over to degree for this problem. So I'll move over to degree, hit enter. Now that I'm in degree mode, If I hit sine of 35, now I get a different answer. So it's very important that you know that your calculator is in the right mode. If your problem has degrees, make sure you're in degree mode. If your problem needs radians, then make sure your calculator is in radian mode. And we actually needed 22 times the sine of 35. So I'll do 22 times the sine of 35 degrees and punch it in, and we get an answer of 12.619. I'm a fan of the third decimal place, so we'll stick with 12.619. We'll grab that and move it over here. Good? Good. So my answer is 12.619. Go to that in the calculator. There's our answer. Let's try it with number 4 here. Look at what we have. We have an angle here. We have this time the adjacent and the opposite. And adjacent and opposite, oh, that's not opposite, that's hypotenuse. What am I thinking? So we have the adjacent and the hypotenuse, that's cosine. So for this problem, I'm going to set up cosine of 58 degrees is equal to adjacent 17 over hypotenuse, which is x, and we have to solve this equation. Now, I will always multiply by denominators to cancel out that fraction. So I have x times the cosine of 58 degrees. These x's cancel. So x cosine 58 degrees is equal to 17. And some of y'all are going to be tempted to just go ahead and punch in cosine of 58 degrees and get the decimal. I suppose that's okay, but remember that's going to be a rounded, ugly decimal, and you're going to have to store that. To avoid having to store answers, I'm simply going to divide by cosine of 58, and I'll punch it in as cosine of 58 degrees, rather than getting the crazy decimal value. So I'm going to divide by cosine of 58 degrees. That's going to cancel this, and I get x is equal to 17 divided by cosine 58 degrees. Go to the calculator. We'll punch that in. What was it? 17. Geez, I've already forgotten. 17 divided by cosine 58. So 17 divided by the cosine of 58. Hit enter, and we get 32.080. 32.080. So I'll go back. My answer is 32.080, and that's the length for x. Something you always want to be aware of when you're solving for right triangles is that your answer makes sense. Remember, in a right triangle, your hypotenuse has to be the longest side. So when I solved for x here, I knew I needed an answer on number 3 that's less than 22, and I got that. So 12 makes sense. Same thing on 4. I was solving for the hypotenuse, so I should get a long side. Should be bigger than 17, and 32 is bigger than 17. So always just make sure your answer is reasonable, even though that is a very simple sense of reasonability. Yeah. All right, last type problem using inverse trig to solve for angles. You have done this before. We're going to set this up the same way we set up the last ones, except here my unknown is the angle. I'm looking at number 5 here, and I have 17, which is the opposite, and I have this side, which is the adjacent. And opposite and adjacent, remember SOHCAHTOA, let's bring her back. SOHCAHTOA. And opposite and adjacent is tangent, so I'm going to use tangent for number 5. So tangent, I don't know the angle though. Tangent x equals opposite over adjacent. And there we go. All right. We need to somehow isolate the x and separate it from the tangent. What a lot of people want to do is divide by tan, and they think that if you divide by tan, it cancels the tan. It doesn't work that way. That's one of the biggest pet peeves of mine is people trying to cancel just the tan or the sin or the cos or whatever trig function you're dealing with. So here, if I want to undo tangent, what we actually do is something called inverse tangent, where I will say x is equal to the inverse tangent of 17 over 10. And that's how you solve for x. You don't divide by tangent. You do the inverse tangent of the two side lengths. That is also sometimes referred to as the arc tangent. It's the same thing. Arc tangent, inverse tangent. And we will punch that in the calculator. If you notice on the calculators, there is, above your trig buttons, you'll see, there it is, inverse sine, inverse cosine, and inverse tangent. In my case, it's blue, which means I need to hit the blue button, so second, and I'll go inverse tangent. So I'll do inverse tangent, and my side lengths were 17 over 10. So let's do inverse tangent of 17 over 10. Hit enter, and I get an answer of 59.534, and this is an angle. So my angle is 59.534, and include the units, which in this case my unit is degrees. All right, one last problem, and then we'll call it a day. I have an angle. This is the adjacent side and the hypotenuse. So I'm going to set up cosine of the angle is adjacent over hypotenuse. And then to solve for the angle, you do the inverse cosine of the other side. So inverse cosine of 5 over 8. And we'll simply go to the calculator and throw that in. So the inverse cosine of 5 over 8. Hit enter. And 51.318. 51.318. So that is my angle measure for x. There we go. There's some basic right triangle trig stuff. We'll slowly add to this as we move through the chapter.